Hi, today's lesson is on function notation. So let's take a look back into grade school. When you first learned about variables, you didn't call them x or a. Most of the time you just got something like this box. So something like something plus 3 equals 5. And you had to think, what would that be? You didn't rearrange the equation, you just used logic. So in this case, you would know that the box is equal to 2. And then later it became more formal, and instead of using a box, you started using a variable. So now we would say x plus 3 equals 5 and x equals 2. You can think about why this is more useful to have a variable. It is much more useful in mathematics to have a variable than just writing a box. So we're going to learn something similar today with y equals. So up until now, you would have something like this, y equals 2x minus 3. And if you wanted to sub in a value for the variable x, you would actually have to write this part down. Let x equals 5. So this can be cumbersome to write, and it kind of takes a lot of time, and it's not really mathematically as simple as it could be. So we're going to learn a way that instead of always writing y equals and having to set let x equals 5, we're going to learn an easier way to do that. So take out your note. So function notation. Let's recall that a function is a relation in which each member of the domain, which is the set of all possible input, corresponds to one and only one value of the range, the set of all possible output. So this is from a few days ago in our lesson about what a function is. So the official notation is this, f at x. So this can be seen as f at x or f of x. And this is what is going to replace y equals. So x is what you put into the function. This is the input. And f at x is what comes out of the function. That's the output. So what does this look like on a graph? Well, here's your function, and instead of calling it y, you can now call it f of x. Okay? And let's say you have a value here, x equals 3. Then the y value here would be equal to f at 3. So basically, when you have a value that you want to put into the function, you put it in for x. So here my x value is 3, so my y value is going to be f at 3, or f of 3. This means what is the function equal to when you put 3 into the equation? So you can use something like f at x, or you could use g at x, doesn't matter. Or if you were using a more realistic example, like height versus time, you might want to use h at t, height at time, or v at t, velocity at time, etc. Okay? So f at a, that's the value of the function when x equals a. So the notation y equals and f at x equals are interchangeable. They mean the same thing. Now, something that's a bit confusing is that this is f of x, or f at x. It is not f times x. Okay, I know that in mathematics, often parentheses like that means multiplication, and that's something that can be confusing, but this does not mean f times x, it means f of x. So let's see some examples, and hopefully this will make some more sense. So, example 1. So we have just a simple linear function, f at x equals x plus 1. This is the same as y equals x plus 1, but it's more versatile. So let's say we want to find f at 3. Finding f at 3 is the same thing as saying let x be equal to 3. So what this means is, what is the output of the function? So what is the function equal to when the input is 3? So when we put 3 into the equation. So f at 3 just means that we let x be equal to 3. So instead of an x, we put a 3. So you get 3 plus 1, so 4. So f at 3 is equal to 4. So this means that the point 3, 4 is a point on the graph. Okay, so when you put in the input 3, you get the output 4. Now let's try this example. If you want, you can pause and try it on your own. So consider g at x is x squared minus 4x. So let's evaluate g at negative 3. So that just means when we put negative 3 into the function, what is it equal to? So g at negative 3, you just let all the x's be negative 3. It's crucial that you use parentheses here. Why? Well, if you don't have parentheses around this negative 3, you might think that negative 3 squared is actually negative 9. But in this case, all of negative 3 is being squared. So negative 3 times negative 3 is positive 9. And then 4 times negative 3, that's minus 12. So minus a negative 12 becomes plus 12. Okay, so just like last year when you were putting in variables, with function notation, also you have to use this, the parentheses. So your final answer here is 21. Okay, so that means negative 3 is the x value and 21 is the corresponding y value. Okay, what if you find g at 1 plus g at 4? Well, first let's just find g at 1. Okay, which is just 1 squared minus 4 times 1. So 1 minus 4 is negative 3. And then we can find g at 4. Okay, so 4 squared minus 4 times 4. So that's 16 minus 16, which is 0. So then g at 1 plus g at 4 is just minus 3 plus 0, so minus 3. Okay, it's important that you understand that this is different than if we had, let's say, g at 1 plus 4. Okay, you might want to think about what this means differently. Well, this means g at 1 plus 4, which means g at 5. So the 5 would be the input into the function, not a 1 and then a 4. Whereas this means find what g of 1 is equal to, find what g at 4 is equal to, and then add the two together. Now, this is something different because we have a variable and a number in the input line. So don't let that freak you out. All this means is that this is now the input into the function. So we're going to find the function at a plus 1. So that means instead of where you see an x, you're going to be writing an a plus 1 instead. So the function is g at a plus 1. So we have x squared, so we're going to put a plus 1 all squared instead. And then minus 4, and instead of x, we put a plus 1. Okay, so again, the parentheses are crucial here because a plus 1 is all being squared. So that really means a plus 1 times a plus 1. Okay, this is not just a squared plus 1. Remember, that's one of my biggest pet peeves. And then you can expand this right away if you're comfortable. Remember, the negative 4 gets distributed. So you FOIL this, and you come up with a squared plus 2a plus 1 minus 4a minus 4. So your final answer is a squared minus 2a minus 3. Okay, so what I'd like you to do is pause the tape right now and try to do g at b minus 1. Your final answer should be b squared minus 6b plus 5. Okay, so we also have some special notation when it comes to domain and range. And you'll be using this all through this year, functions, and next year. So this is important that you get used to this notation. So before we've just been talking about x can be any real number, and I've just had you write out x can be any real number. But math has some cool way of saying this without having to actually write that all out. So for domain, saying that x can be any real number, This is how you do it, okay? So this is the set notation, these curly brackets. So it's the set of all x values such that x is in the set of all real numbers, okay? So this vertical line just means such that. And this kind of curvy E means in the set of. And this R with the two lines there means real numbers. So that means that the domain can be any real number. Okay? So what if we wanted to restrict the domain though? So what if we wanted to say that the domain is only anything greater than or equal to 0? So we still start with our curly brackets. And if we're using the variable x, we put x so the reader knows what variable we're using, such that now we put the restriction. So x is greater than or equal to 0, comma, and then we want to tell the reader what kind of numbers can x be. So let's say that x can be any real number. So this reads x such that x is greater than or equal to 0, and x is in the set of all real numbers. So x can be 0 or anything above it. What if we wanted to only do integers, let's say greater than 10? So, and let's say it was number of yearbooks. So we're saying n is our variable for the number of yearbooks. N has to be greater than or equal to 10, comma, and n is in the set of integers. Now you might think it's an I, but actually it's this fancy Z. So that means that we're using n as the variable, n has to be greater than or equal to 10, and n has to be an integer. Now what if it has to be between two numbers? Let's say between 0 and 10. Okay, so let's do, let's say t. So let's say we're doing something with time. And then you put the smallest number here, and then the biggest number. So t is between 0 and 10. It has to be greater than or equal to 0 and less than or equal to 10. And then time is a real number, so we tell the reader that it can be any real number. Okay? Range is the same thing, except that you use y. So this means that y can be any real number. How about you pause the video and try to do something in the range that y has to be less than 6, and it can be a real number. So you start with your set notation. Now it's the range, so we're using y, such that y is less than 6, and we're letting y be in the set of all real numbers. And you end with your curly brackets. So the generic form for this is, you start with your variable, such that then any restriction you might have, comma, your variable is in the set of, and then whatever type of number it is. So if there's no restriction, then you just don't have this part. Like these two examples don't have any restrictions, so you just go right to the second part where you say your variable is in the set of, and then whatever type of number you want it to be. Okay, so if you're given a function and I ask you what the domain and range are, you can now use the proper notation to tell me this. So this is a quadratic. And let's think about what this looks like. The a value is positive, so therefore it opens up. So it looks something like this. Okay, we don't know where it is. All I really care about is that you can visualize that it's a parabola opening up like that. So we know that a parabola can have the domain of any real number. You can put anything into that function, nothing's going to break it. Any x value works. So your domain is x such that x is in the set of all real numbers. But what about the range? Well, if you're going up or down, it has to have a lowest point. And I know it's a lowest point because it's opening up. If we're opening down, it would have a highest point. So my range is going to be y such that y is greater than or equal to something, and instead of all real numbers. Well, what is that something? That's just the y value of the vertex. So that means we need to find the y value of the vertex in order to finish this range. Well, to find the x value of the vertex, we use minus b over 2a. So minus 3 over 2 times 1. So minus 3 over 2. And then we can use our function to find y. So we want to find f at minus 3 over 2. So remember, this just means what y value happens when you put in minus 3 over 2. So you can use your calculator or go by hand, and you'll see that you get minus 29 over 4. That's what you get when you put minus 3 over 2 or minus 1.5 into the equation. So this is the y value of the vertex. So therefore, the range is y such that y has to be greater than or equal to minus 29 over 4, and then it can be any real number. This example is about a mine reaching into the earth, and we know that the temperature at the top is 11 degrees, and the temperature is actually going up the further you go down. So we want to represent the situation using function notation to find the temperature at the bottom of the mine. So we want to find the temperature as a function of the distance that it is down. So we're going to use capital T to represent temperature, and we're going to say at depth. So what is the temperature at a certain depth? So this represents the temperature in degrees Celsius at depth D in meters. So what I've done here is I've been able to describe the temperature, which is the dependent variable, and the depth, which is the independent variable. And notice I use function notation. So I want to write the equation using function notation. So T at D equals, well, we start at 11 degrees, and then we add 0.015 degrees per D of depth. So we want to answer the question, what is the temperature at the bottom of the mine? Well, we know that it's 3585 meters down. So we want to find the temperature at 3585. See, that's so much easier than actually having to write let D equal 3585. We're telling the reader that in that one simple notation there. So now you just substitute in 3585 for D, and you get your final answer of 64.775 degrees Celsius. Okay? And you would write a sentence. So that's function notation. I hope you learned lots.